Space is a massive structure where everything moves in an uncertain direction. And then there's time. Early theories suggested that time was the same everywhere, meaning time on Earth was identical to time on Mars, or even in a structure millions of kilometers away from us. But later studies, analyses, and mathematical calculations from certain scientists showed that this couldn't be true. Because space and time are not two separate structures, they are connected and move relative to one another. Today, we'll explore why these two mysterious entities are intertwined and what this means for us. Before we begin, don't forget to subscribe to my channel, like the video, and share your ideas for new topics in the comments. Now, if you're ready, let's dive deep into the nature of space and time. According to Newton, time was identical everywhere in the universe, flowing the same for everyone, no matter where you were, and space was fixed. Planets, stars, and galaxies were simply celestial bodies moving here and there within this space. Newton imagined the universe like a clockwork mechanism, orderly, predictable, and governed by fixed laws. For more than 200 years, his ideas were accepted as scientific truth. But in the early 20th century, Albert Einstein's theory of relativity completely transformed this understanding. Einstein claimed that space and time were not independent, but instead formed a single fabric that could change based on movement and gravity. This structure is shaped and curved by all matter and energy in the universe. The greater an object's mass, the more it bends space-time, and this curvature is what we perceive as gravity. In daily life, we don't feel this relationship between space and time, but time does not flow at the same rate everywhere. Time slows down in regions with stronger gravity and flows faster where gravity is weaker. This is not just theoretical. The GPS satellites we use today would accumulate errors within minutes if we did not account for the bending of time. In other words, even modern technology relies on the fact that time itself warps. One extreme example of this relationship is the mysterious black holes. These structures contain an enormous amount of mass within a tiny volume, causing space-time around them to bend in unimaginable ways. As you approach a black hole, the flow of time slows almost to a stop. Theoretically, someone hovering at the event horizon could experience just 1 second, while billions of years pass in the outside universe. Black holes don't just distort time, they are so powerful they can bend light, creating what we call gravitational lensing. Today, we observe these lensing effects through telescopes as they magnify light coming from galaxies behind them. The delicate connection between space and time applies not only on large scales, but across the entire universe. Since the Big Bang, the universe has been expanding, and this expansion shapes time itself. Cosmological observations reveal that the universe's expansion rate changes over time. The mysterious force known as dark energy, which we discussed in earlier videos, accelerates this expansion more and more each day, affecting the flow of time on a cosmic scale. To better understand space-time, scientists conduct both observational and experimental research. In 2015, the LIGO and Virgo observatories directly detected ripples in space-time, called gravitational waves. These waves are produced by massive cosmic events, such as the collision of two black holes, and they create vibrations in the fabric of space-time. This discovery confirmed Einstein's predictions once again and shifted our view of the universe. But the story doesn't end there. Quantum physics shows that, at the subatomic level, space and time behave in a far more chaotic way. Quantum gravity theories represent one of the biggest mysteries in modern science. Is space-time truly continuous, or is it composed of quantum units at the smallest scales? String theory and quantum gravity models suggest that space-time might have a fundamental structure, much like atoms, implying that at the smallest scales, time itself may lose its meaning. In addition to all of this, the question of what the direction of time is, or whether it can change, is another topic entirely. As you know, when people talk about time, they often mention either traveling to the future or going back to the past. Some want to travel to the future to see themselves or the people around them, while others want to go to the past to change things, either to become rich or to fix their mistakes. So is it possible to travel to the future or the past? You may find this surprising, but traveling to the future is possible, and it has been proven. Through what we call time dilation, traveling into the future is achievable. According to Einstein's theory of relativity, time slows down for someone who moves at extremely high speeds, and time also flows slower under very strong gravitational fields. That means if you board a spacecraft traveling near the speed of light, when you return to Earth, many people will have aged far more than you. In fact, if you travel long enough, you may return thousands of years into Earth's future. This is a scientifically proven reality. Astronauts in space and GPS satellites experience this, although on a very minimal level. For example, if you're in a spacecraft traveling at 99% the speed of light and your mission lasts 5 years, Those 5 years for you could equal more than 100 years on Earth. In simple terms, that is time travel to the future, because by the time you return, even the youngest person you knew could be long gone from old age, while you've only aged 5 years. Traveling to the future doesn't create many paradoxes or problems, but traveling to the past is much more confusing and leads to far more paradoxes. Some theorists believe certain models could allow time travel to the past, such as wormholes, rotating black holes, and cosmic strings. However, none of these theories have been proven or tested, and we currently have no practical method. They remain theoretical assumptions. When we talk about time travel to the past, the most famous paradox that comes up is the Grandfather Paradox. According to this paradox, if you go back in time and kill your grandfather, your father would never be born, and therefore you would never exist. But if you never existed, then who went back and did it? And if you didn't exist, how did you kill your grandfather in the first place? Another paradox is the Bootstrap Paradox, where information or an object goes back in time and becomes the cause of its own existence. For example, your future self gives your past self the blueprint for a time machine. Then who originally created the blueprint? This leads to an endless loop and becomes logically impossible. If your past self and future self meet, it creates physical, quantum, and informational consistency problems. Many scientists believe traveling to the past is most likely impossible, while others argue that the universe has mechanisms to prevent such paradoxes. For example, Stephen Hawking famously said, "If time travelers exist, why haven't we seen them yet?" and proposed the chronology protection conjecture. Truly, if traveling to the past were possible, a future civilization, whether humans or something else, would have already built such a machine and visited us. Even if, let's say, 10 years from now, scientists do find a way to go back in time, that opens up another huge problem. Powerful nations could alter history. For example, they could go back and change events that negatively affected their nation. But here's the issue. If someone goes back and changes the past, creating a new outcome, what happens to the timeline we're currently in? How does it disappear? Because of these universal barriers, scientists say that while traveling to the future is possible, traveling to the past is just as impossible. However, some theorists suggest a possible escape from this issue. According to certain quantum interpretations, if you travel to the past, you cannot change your own timeline, but instead create a new branch of the universe. Meaning, if you go back and kill your grandfather, you would still exist in your original universe. But your action creates another universe where you never exist. This theory appears to be the only logical and realistic solution to paradoxes. But the biggest question here is the existence of parallel universes. If parallel universes are ever proven, and if we can interact with them, then time travel to the past may genuinely become possible. The topic of parallel universes is even more mysterious and fascinating than space-time itself. We will explore that deeply in another episode when the time comes. In short, time can bend and change depending on masses in space. If you stand near an ultra-massive object, time for you will pass extremely slowly. If you land on the surface of some massive planets, time for you might nearly stop compared to Earth, meaning an hour for you might equal a month or more on Earth. As you can see, the universe surprises us in every way, and we know almost nothing compared to its complexity. Even though technology has advanced and we have a great deal of data, there is still so much about the universe and its laws that we do not know or understand. Hopefully, our generation will find answers to many of the mysteries we wonder about today before we disappear from this planet. Unfortunately, that's all from me for today. Before ending, don't forget to subscribe to my channel, like the videos so they reach more people, and share your ideas for new videos in the comments. Until the next video, take care of yourselves. Goodbye.